There's a couple questions on the midterm, and instead of trying to do all this and kind of waste time, I'll just kind of give you the gist of it. We have learned about this, we've talked about it, it should be in your notes. There is examples on my website. So the website is a good thing. If I'm telling you, like yesterday, the Maxwell distribution curve, the internuclear distance curve, you can Google it, look in your book. But the website, I already found all these like links. You just click on it and it'll show you what I'm talking about. So I really think you should look at that. Here's the one, literally just found it last period. Just because I want to give you an actual example. Alright, whatever. So let's say you have a mass spectrometer of mass spectrogram is what this is called, of let's say I don't know, copper, and you end up getting okay. So let's say this is a mass spectrogram of copper, and down here is the atomic mass. Again, I'm making this up top of my head. I had one set up. I don't know what I did with it. So let's say this is, oh, you know what? This should actually be more like this.
Wow.
Well, I'm trying to make it up as I go here, and it's got to make some sense. So if this is 64, 63, 62, 61. This one's probably going to be really little. Same with that.
Are you kidding?
If you just want to pay attention, that might just be better. Instead of trying to copy it down. Alright, so this is like abundance or percentage. So what does this tell you about copper? Because there's two on the test there's two of these on the test. And I felt like I need to at least show you one and kind of refresh, otherwise you're gonna get to it. Be like, what?
The amount of copper that's has an atomic mass of 64, 63 is
So-
the high.
So, how many isotopes of copper are shown?
Four.
Which one's the most abundant?
64.
Okay, but 63 is pretty high too. So if you look over there, why does that make sense?
Because that's what's on there.
Right, so it's right in between, am I right? 63 point. So technically it should be, maybe almost all the way. Okay. So again, I had one for bromine set up here, but this is the gist of it. All right. This is, I don't know if you remember, but you ionize these things and they put them through a magnet and it gets bent. We talked about it, and it spits it out. Basically, based on the magnitude of charge and the different isotopes, it is deflected by the magnetic field differently. So it hits these graphs at different points, but really digitally the computer just kind of spits this out. But anyways, you don't need to know the whole process, but this is one way. You take an unknown sample, it's got to be in the gas state, and you can get one of these, and then you can say, what's in this unknown gas sample? In college, if you take organic chem, you'll do one of these, and instead of copper, it's like a mixture of hydrocarbons, and you can figure out like what's in your unknown sample based on the peaks. And there's like reference books, and everything's probably online now, but when I did it, they were like these big fat books, so we would get this, it would print out on like old school paper. You guys ever see the green and white lined paper with like the holes on the side? Yeah, like that. And then anyways, but that is not really what you have to do, but this is something you're going to see. All right, so these different peaks represent different isotopes. If it was a mixture of two elements, then you would have other peaks, obviously, with different masses. But I just want to at least refresh your memory. So if you want to look up more with that, I got the links on my website. We have notes on it. There's a little bit in the book about it. It should be on the review sheet too. But that was something I felt like I needed to bring up. Otherwise, if you don't review it, you're going to be like, what is this? I'm not going to do a limiting problem. because we kind of already have a couple of review classes ago, but you need to use that, apply that a few times. All right. So just reiterating that there are kinetic problems with steps. How do you know which step is rate determining? Slowest. And what does that step give us?
The rate.
The rate law, right? And the coefficient is the exponent in the rate law. So you do need to know that. Mechanisms, steps, same thing. The gas law, PV equals nRT, you will have to use that for sure. Let's see. Oh, diffusion and effusion. What's the difference?
Effusion is like when the gas goes out of the small hole.
Right. If you have a container and you put a hole in it, gas comes out of it. That's effusion. If I spray body odor, body spray, Axe, whatever, something like that in this room, it'll diffuse through the room. So that's diffusion is when it moves from high concentration to low. Effusion is not a whole lot different, except effusion is very specific. Is you have a container with a tiny pinhole put in it and gas comes out. That's just definitions. The test isn't going to ask you about definitions. You just need to know what the words mean, or the question's going to be confusing. Who effuses faster? Big molecules or small?
Small.
Small, right? Do you remember the equation for calculating the speed?
The URMS one.
Yep, URMS, which is basically velocity. Square root
The square root
of
of
3RT
3RT.
over molar mass in kilograms per mole. I don't think that's on your equation sheet. But the molar mass, right, the smaller it is, the faster, the larger V, right, the velocity or URMS. Diffusion, same thing. If you have small particles, they will diffuse faster than large particles. That, it's just conceptual. I don't remember if there's calculations with that, but just in case, try and remember that equation. I really can't remember. I'm not misleading you on purpose. A lot of force of attraction all over the place. Okay, dispersion, dipoles, polar, nonpolar,
Wait,
Coulombic.
what did you say?
What's that?
Dispersion?
Yeah, I'm just kind of listing all the forces. So be ready to bless you. You know, be ready to explain. There's forces of attraction questions on part 2 and part 1. Like dissolves like. You can think that. Don't write it, but think deeper, right?
Can we write it and
and
then
explain
explain
it?
it?
Sure,
You
fine,
say
fine. If
that.
that makes you feel better, fine. But I'm not literally not even gonna look at that. I'm gonna look at what comes after it.
Okay.
So,
I just said the same thing.
you know, so just keep that in mind, like why something might dissolve in water or why it might not.
Why? Can you explain right now?
Yep.
Yeah.
What dissolves very well in water? Well, some ionics do because you have the charges, right? You got positive, negative ions attract to the partial charges on water because it's polar, with the dipole moment. What about, so that's ionic. What about something that is organic, but it dissolves really well in water? So organic, you think, well, it should be nonpolar because most of them are. And let's say it has dispersion, everything does. What other forces do you think organics have that make them very soluble in water? Hydrogen bonding, right. Almost all organics have C's, H's, and O's, except for the hydrocarbons. They don't have hydrogen bonding, they don't have any oxygen, nitrogen, or fluorine. So hydrogen bonding is on there a few times, but it's kind of in conjunction with other forces. So that's why I'm telling you need to know about force of attraction. Did that answer your question? If a gas has a higher velocity, will it have more kinetic energy? How do you calculate kinetic energy from speed? It's like those two equations we used. So V or URMS, basically velocity, equals square root of 3RT over molar mass. How would I figure out the kinetic energy of those particles? So let's say it was 300 meters per second was the velocity. How would we get the kinetic energy? This is on your
One
equation
half
sheet.
and these.
1/2 mv squared, right, you can take that and plug it in for v. So what am I explaining? If you know the velocity,
Wait, 1/2 mv squared?
yeah. Again, a lot of, the gas, you will have to use the gas, PV equals nRT. The whole, kinetic energy, effusion, diffusion, like how fast these things move, just understand that if this is, so this is calculated from a square root of 3RT over molar mass, right? So we get that. If you have two particles that have a similar mass, their kinetic energy will be the same or similar, right? So if their molar mass or mass is the same, then their kinetic energy will also be very similar, right? So what I'm really trying to explain is, if you know the velocity, you can compare large or large versus small in relation to each other. Speed is really what it comes down to. If you understand big ones move slower, little ones move faster, I think you guys should be fine. But just keep in mind, I personally think these help me answer certain questions because I know how they relate to each other. So this can plug in here. You can answer some of these questions like conceptually. You don't need to do anything with these. I'm just trying to remind you these are connected. That's all. All right? That's what review's for. Partial pressure. How do we find the partial pressure of a gas? P1 equals the molar mass times the, that's on your equation sheet too. There are partial pressure questions. There is a question, there's a few questions. I want to say there's like 4 boxes or something with different gases, and there's like a series of questions based on that. This is, you're going to have to use partial pressure. Okay? And the gas law, PV equals nRT. Remember, multiple choice, no calculator, so the numbers are manageable. You can still plug numbers in if they're numbers you don't need a calculator for. So don't, when you get to those questions, don't freak out. Just plug them in like you do have a calculator, and then go from there. So I'm telling you, this will help, and PV equals nRT will help too.
Can you give us, like, anything?
I can, I'm trying to really just give you as much of, you need to know this specifically, before I get into any practice problems.
So do we need to know all the different names for the geometry?
Yeah, I was just
Oh,
gonna
that's,
ask
that's
that.
interesting you asked that.
Oh
I was
god.
literally just gonna ask
All of those.
you that. Yeah.
I don't even know if there's a geometry question as far as
Would it
like,
be, like,
is this
multiple choice, though?
tetrahedral? Yeah, it's
It would
multiple
be,
choice.
okay.
But you, on the part 2 though, there is a question that it asks about bond angles. So you do need to know about bond angles. But if you
Is
just
it like why are bond angles different if you have a lone pair?
right, that's it's general. It's a general thing you guys should be good with if you learned it the first time. In other words, if there's a lone pair, it increases repulsion. So if it says, okay, this angle appears to be this angle, but it really isn't, explain why. I think you guys can probably handle that.
Wait, what do you mean?
So if it says, this bond angle should be 120, but it's not, explain why, and they give you a picture.
And it's usually like the one pair.
Yeah, I mean, I'm not going to give you much more, and
Yes.
it's not 120. That's not what they tell you. You will have to draw a Lewis structure. You will have to draw a Lewis structure, and it's an organic Lewis structure.
Those
But
are
it's
the
simple.
ones with like the
It's
this
simple.
and the dot dot dot.
You don't have to do those.
Okay.
I do that just because I enjoy it. I think it's fun. But
Because
you don't
you
have to.
told us
that.
we
I
had to
hate
know
that.
that.
No, I don't think you did.
No,
I don't think he
don't-
specifically.
I usually, I really don't flat out just
No,
straight up
for
lie
his-
about things.
That's how he
I'll
does
just,
it.
Well,
You're
no,
kinda-
you told us we had to know it for your quizzes.
right, and then actually, if you take organic chem in college, some professors make you do that. So I'm not crazy. I mean, that does happen. All right. Anyways,
So Lewis structure is just like lines.
lines or
Or
dots,
dots.
either one. The bonds you can draw lines, and the ones that don't bond, dots.
Okay.
All right. So just
We have to
don't
find the ones
forget
that, like,
the octet rule, full valence shell. So there might be multiple bonds. Okay.
Do we have to like know like the ones that like connect to each other?
I don't know what that
Like,
means.
it's like, what do you know about?
What do you mean?
It's gonna say, here's the formula. Draw the dot structure.
Okay.
Draw the Lewis structure.
We don't have to like connect anything.
No,
What is it?
I don't even know
It's
what that
like we
means.
did
Are they just talking about like forces?
Yeah,
Yeah,
like
like
hydro bonding
forces,
between
yeah.
like two and like where would they connect and like you
Ooh.
find like the end.
Yeah, that's on there somewhere.
HF.
It's either
See?
multiple choice or short
That's
answer.
stupid.
You don't have to draw it.
Yeah.
It's given it.
But, like,
It's
yeah.
showing you, and you have to explain it.
Yes.
Yeah,
That's
that's
what I'm
different than
asking.
drawing. That's totally different than drawing.
I
I
didn't
Um,
ask
Okay, moving on.
Like, if you have two different types.
Oh,
they can-
when bonds form,
Like,
what happens to energy? Released or absorbed?
Release.
Released. And then to break bonds, energy goes in. Remember that. Oh, there's a great question. Great question. Sometimes I read these questions, I'm just like, this is a great question. I don't excited about it. Probably from your perspective, you would not agree. But there is a question, and I'll just give you a little hint here. It's like a series of, it's a picture, and it gives you a series of things that happen. You have to keep track of the energy changes throughout to answer the question. So if you understand,
Wait, what? Sorry, repeat that whole thing.
there's a question with a series of pictures. You have to pay attention to the series, look at it, and pay attention to the energy changes for each one. And then you can ultimately answer the question. But
So it's like boiling.
just
or like
no, it's not that simple. If you just remember, forming bonds is exothermic, right? Losing. Breaking bonds is endothermic. Remember that. What about forming solutions? Is that favorable or not favorable? We just kind of talked about that not too long ago. Well, if the solution
Yeah.
forms.
Oh.
If a
that's
solution
okay.
forms.
If the solution forms.
Is that a good thing for everybody involved?
No.
Yes.
Oh.
Solute and solvent. If a solution forms and it's exothermic especially, that means the solute solvent interaction is stronger. So remember that phrase, systems in nature tend to progress towards high entropy, low energy, meaning they get rid of energy. Okay? So solution formation, bond formation. Check, check. Moving on.
Exothermic?
What?
Solution formation, bond formation, both exothermic.
It should be, yeah. Some solution formation, though, is endothermic. It'll still form a solution, but it's got to take energy from the surroundings because it's not as favorable. The question isn't that confusing. I just want to give you the hint that you need to know those things to get. And it's not just that's one question, but those apply to other areas of the test as well. N and P doping in alloys.
Okay.
So N doping is when you add a metal or semi-metal or non-metal that has one more electron, that stands for negative. And the P doping is when you add an atom that has one less. So now there's a hole. Either way, it increases the conduction of the alloy. Right? Because if it's adding an electron, it jumps up to that conduction band because there's no room for it down below. Do you
Oh,
guys
is this the
remember
staircase
the loft?
thing?
Yeah.
Yeah.
So you want to get up there, and that's the conduction band. And then if there's a hole, then that allows electron movement as well, because then one can come down and fill it, and then it'll start conducting. I'm being very quick and brief there. You can look into that. But that's, and so, like silicon, phosphorus, aluminum or gallium, right? Those are the ones we've learned about in class, like Ga. So if you have silicon but you dope it with gallium, that would be P doping. If you dope it with phosphorus, that would be N doping, because phosphorus has one more valence and gallium has one less. Speaking of alloys, two types: interstitial, substitutional. What's the difference?
Interstitial is when like they go into the
Right.
holes.
Right. So interstitial. So you have the big ones. Interstitial is that, and then if it was substitutional, you would have these. You take this out and put in
One with a
a
similar
different one, similar radius. Right. So just know the difference between those two. So PES, I told you this the other day, but I was looking at, there's a part 2 question. You need to make sure you can read the peaks, right? Know what the peaks mean in the PES. Photoelectron spectroscopy, I have trouble with that word. And just remember the ionization energy or binding energy. If it's closer to the nucleus, you'll have a higher energy. If it's further away, it's lower, and the graph shows this. You just need to be able to read it. All right, and the shorter peaks have less electrons. Taller peaks have higher. So I know I gave you some worksheets on that, and I think I have the website, our website linked on my website. And it would be good to go before you take the test, look at one and just kind of see what's going on. What was that? Sound like a-
Ambulance or like a police?
Sound like a jet.
Yeah, the alarm.
Just-
It
went
was a jet. They're gonna land on our school.
off. The like fireworks.
Oh yeah, that one was like a paramedic.
Lattice energy, we talked about it. There's a bunch of times that pops up. I told you about hybridization, chromatography. All right, I'm just gonna throw this out here because this question made me laugh because I'm not sure I know how to answer it. So
That better not be on the test.
it is.
Take
So
it off.
here's
Take a
here.
bonus.
I'm telling you what to look
Bonus.
up. I'm telling you what to look up. Look up what type of light is emitted or absorbed
Hold on,
when
slow down.
molecules vibrate and rotate.
What type of
So when,
light?
when molecules vibrate and rotate, what type of light is emitted or absorbed? Because
When molecules vibrate.
or rotate. So for example, I know I have the answer key, but it's a hard question. When I first read it, I remember a couple years ago, I was like, man, I knew it wasn't. There was one I could eliminate. The other three is a little confusing because visible light, for example, doesn't do that. Visible light isn't going to rotate molecules and vibrate. Other types of light can, which can create heat. So let's think about one type of wave that can create heat.
Heat wave.
Micro.
That was funny. That was really funny. Heat wave.
Microwave.
Microwave. Good. What else?
Infrared.
Right. So, all right. Now you're thinking. Moving on.
Wait, was it right?
Wait,
Uh,
what?
Okay.
Was that right?
The answer's gonna be like.
Yeah, those two involve heat. Yes,
I just guessed.
but that's not necessarily the answer to the question. I'm just telling you now you're thinking.
Oh,
You will have to write precipitation reaction. Oh, no problem.
Thank you.
You will have to write a precipitation reaction with a net ionic equation.
Oh. I
Solubility rules. You will have to write a neutralization reaction. So I will be nice and go through one with you.
Wait, a precipitation.
Wait, what was that one question? With the light.
Oh, so molecules that vibrate or rotate, what type of light would either induce that or be emitted from that? Or absorb or emitted. So again, like visible light doesn't do that. Visible light, well, what creates visible light? The electron transition, right? Okay? Right. So that's not what necessarily creates all types of light on the electromagnetic spectrum. Sometimes vibrating and rotating molecules or atoms can create different type of light.
What do you mean by
That's why it's a hard question.
rotating?
That's a classic question. I put it on a midterm. I left it there because I want you to understand you're going to get to the AP test, and there's going to be some swirly questions. You're going to be like, where is this coming from? All right, and that's just the way it is. And you're going to have to take everything you learned, and there's going to be something in the question you can relate to, or you have learned or heard, and you have to figure it out. And that's part of the test. So it's a good experience, even though you don't want to hear that. Here we go. What if we have, I'll give you a kind of simple one, HCl plus CaOH2. Let's say that's your acid base. What would the products be?
CAC.
You're close.
Oh, CL2, right?
CaCl8.
And H2O. I write HOH just because it helps me balance it a little better. Oh, wow, I made a huge mistake. Hey, crucify kids for it. What'd I do wrong?
You have to put 2 for the HCl.
2H.
No, not balancing in my formulas.
The grit, like the gas, liquid, that thingy?
My formula's wrong for one of them.
Oh, parentheses?
Yeah, that's a big problem. I'm gonna lose points on that one. There's 2 OHs, not 2 H's. And yeah, now we gotta what? Put a 2 here and a 2 here, I think.
I think any of your lost points should go to us.
What's that?
I think any of your lost points
Should go to you. Fair enough.
That's a minus 15.
Right.
Oh, look at us, we're passing already.
So there's your, that's just an equal, or neutralization, acid plus base. You always get water and some sort of salt, which is an ionic solid. This is not the one you have to write, but you'll identify the acid, 'cause it's the one with hydrogen. And the base is the one that doesn't have hydrogen. So that's a very simple one. You guys should not have a problem with that. Beer's law. What's the graph look like? You guys remember?
What is what?
Beer's
Sorry.
law.
Beer?
Beer's law. It's a straight line.
Please do.
What's the equation for Beer's law? A equals ABC. B.
Oh, yeah. B is one.
B is 1 in this lab. It might not be 1
Well,
tomorrow.
that's stupid. You
Or
told us it's a
whatever.
universal one.
It is.
So it's gonna be one.
Wait, what?
What's C?
Wait, what do you,
The
if it's a
constant-
universal one, how's it not?
Just hold on, I'm getting there. What's this?
Concentrate.
Concentration. What's this?
Absorbent.
Molar absorptivity. That's the slope of this line. And what's this?
Absorbent.
So if the slope is little a, what's y and x?
A and B, C.
Right, and B is just the
B is
width
just
of
one.
the cuvette. It's not going to affect this. Well, if it's 1. So
I swear,
It's-
if it's not one,
listen.
I will.
Here's
walk
what
out.
the AP test loves to do. It loves to take what is like normal or common, and then they say, okay, so there's your answer for this part. Here's this part. We're going to change this one value. Explain how the experiment would change. So be prepared for that with this Beer's law question. Okay. So if you know this equation and you know what this graph looks like, everyone here will be fine. I promise. But you need to remember what this looks like, and you need that's on your equation sheet anyway, isn't it?
No.
It's
Pretty
A,
sure.
B, C,
Yeah. So just remember, the slope of this is that little a, and the relationship would be y over x. So what is this really telling me? The change in concentration or absorbance is directly proportional, essentially, right?
Yep.
That makes sense?
Yep.
And we talked about this, that if you have a really dark solution, it's going to have a high absorbance. And if you have a really low, light colored, right, dilute, it's going to have a weak, and most of the light's going to go through. Okay. Kinetics. If it's first order versus second order, what's the difference with half-life? There's one big difference you need to remember for the midterm. First order, second order. Which one does half-life stay constant?
First order.
Right. Remember that. Second order, it changes. Remember that. Okay? You guys with me here?
Yeah.
Okay, so in part 2, there's going to be a kinetics problem, and there's going to be data given to you. You're going to use that data, and you can figure out the order based on the half-life. I'm giving you like golden eggs here. So just remember, first order, the half-life stays the same. Second order, it changes. So if you're given data, that's one way to identify the order. If you don't have, a chart where you can fill it in and like all the ones we've done in the homework and notes, where you take like reaction 1 divided by reaction 3 and figure it out, oh, that's first order, that's second order. If they don't give you that kind of data, but you can still figure it out through half-life. And you know the 2 equations, you got those. All right, there is one question on KSP, which we're going to learn tomorrow. Now, I know you're like, that's not fair, but it's a really easy question. What did we learn today about KSP? I told you just one thing you need to remember.
The name.
No.
KSP.
The larger the KSP value, the larger the cycle.
That's all you need to know.
Wait, what?
Okay?
So larger KSP.
The bigger the
more
KSP
soluble.
number, the more dissolved, the more soluble it is. The lower that KSP. And it'll make way more sense tomorrow. And that's not so bad. You're going to learn it tomorrow and then take the question, take the test 2 days later. That's not so bad.
What if we take forever, like,
You will understand it, I promise. That's not something you need to really stress. It's one little thing. In fact, yeah, one little thing. Okay. So, there's a question where it gives you a series of reactions. Now, this question looks really intimidating. When you read it, you're like, what are these reactions? Okay. Use the reactions to answer the questions. I'm trying to be nice, but not too nice here. There's going to be a question involving like creating your own procedure, kind of. Just use the reactions they give you. I don't want to have to say it during the midterm when it's in front of you. That makes me feel like I'm giving you too much help, so I'm telling you now. there's a question where there's a whole bunch of reactions. It's gonna seem like when you get to the procedure part, some of you are gonna maybe freeze and be like, how am I supposed to do this? If you just use the reactions, everything's right in front of you. You just have to think about it. You have to use your brain a little bit, but everything's there. You don't have to come up with anything on your own. It's all right there. That's the biggest thing when I went over it, because I will go over this when we're done, down the road. 2 years ago, kids were like, that's all I had to do. I was so worried that I had to like make things up. I didn't know what to do. And right, you don't have to make anything up. It's right there. They give you all your information. So that's my hint on that one. Merry Christmas. Hold on. Oh, this is a big thing. This equation right here, what's the unit on Q? It's got to be joules or kilojoules, not joules or kilojoules per mole. I know there's a lot to remember, but I'm just trying to give you everything I can here. If you have to go, go ahead, but I'm gonna, you guys don't have to go. I'm running practice, so stay here.
My stuff's in my car.
You're killing me. What about you?
Same.
All right, go ahead. What about you?
I'm not locking something.
All right, yeah, hang for 5 minutes.
Coach Ray and
I need another bus pass.
He had his tooth cracked or something, so he's at the dentist right now. So,
I'll give you my keys. Come, or you can do it as a friendship. Tristan?
where are you going? Oh wait, this is you. UK.
Me. LK.
LK.
Ah, third time. Come on. Keep up.
Nima.
It's okay,
Yeah,
What's your
get more knowledge.
You wrote Chi Chi.
RB.
Did you write Chi Chi on it yesterday too?
No, I wrote Cheyenne. Sometimes I can't remember your name fast enough.
That's so funny.
RB.
Yeah.
Isn't
I don't know
Reesville towards Westerlo? Doesn't that stand for Reesville?
Westerlo is 143.
Yeah, but
That's like-
you live like on your way to East Burnham,
Yeah.
so that's
I
what.
don't know.
Yeah, I don't know either how they do it.
I take-
We're not meant to question it, just follow it.
Yeah.
All right. So let's see. There's only a few more things here I want to talk about. I talked about that. Talked about that. Talked about that. E equals HV is on part 2. Just throwing that out there. Make sure you understand. That's frequency. Planck's constants given to you. Energy that is associated with one of two things: either light waves or electron transition. So that E can be used for giving energy to electrons to excite them, or if they fall, they can give off that, which corresponds to the energy in light. So then you have this one, C equals lambda. All right, so the energy affects the frequency, which affects the wavelength because that's a constant. So, but in part 2, there's a question talking about different types of light and energy. So there's that. And one more thing here. I kind of went over all that. There's a tough percent mass problem. I'll give you a little hint on that. So if you have a mixture, let's say you have a mixture of NaCl and KCl, and let's say there's a mixture of 5 grams, and it goes through a bunch of experiments, and it's determined that the NaCl mass is 2 grams. So this is given to you. Question wants to know what's the percent Na by mass in the original 5 grams. So, you know what? Maybe we'll just do this tomorrow in class with everybody.
Okay.
So, that was it. I actually got through everything on that I wanted to give you there. So,